Hi, yeah, so I'm Mercedes. I work at Sensu. I'm going to talk about open source monitoring tools. I changed my talk title a little bit. Sorry, Jason, I forgot to tell you. When I was originally coming up with the topic, I felt a little bit of imposter syndrome since I've been working just as a software engineer and not on call, not doing any sort of cool monitoring things. So I was like, what do I do? And then I realized I had this good opportunity to talk about all of the cool process and things that I've learned in developing products for people that are other than myself to consume. Let's see. Okay, so a little bit about myself. I've spent some time doing on-call. Up until last year, I was doing ops and data infrastructure, and I now build software that wakes people up in the night, hopefully with good reason. And so as someone who's been there, I put a lot of care and am very conscientious about building software that works properly and that does not give you those, basically those unanticipated alerts. And also, I'm Benzobot on the Twitters. I work remote from a farm, so fair warning, if you do follow me on Twitter, you'll see a lot of chicken pictures. So today I'm going to talk about the motivations behind building open source software, why I was really intrigued in doing this and what I've enjoyed about it so far, the different types of testing and what we can do to ensure our code is feature complete and performant, especially when we can't drink our own champagne, since we don't have any infrastructure to actually run this stuff. I'll dive into some of the weird and wonderful bugs that we've discovered along the way and how we fix them, and then I'll chat about the importance of our community and what we're doing to include and learn from it. So a couple of definitions, just to start us out with. Open source is code that is publicly available and accessible to people to use, share, and modify. I would extend that to include a license, so it tells you how someone can use it, how they can contribute to it, and where they can find it. Anyone can put code out in public, but it's to really be open source, you have to tell people these things of how to use that software. So my motivations, and I think this I can say pretty assuredly from people that I've talked to, these are also other people's motivations, is that much of our software relies on open source software in their daily work. And even tools that we pay for are built on open source technology. So it's really, really important that this stuff works and is accessible to us because our industry revolves around it. I want to build and maintain tools that make people's jobs and make people's lives easier, and I want those tools to be performant. I don't want to be waking someone up in the middle of the night because I didn't write something properly. This is gonna happen, so we need to just make sure that if there's a very good reason for it or there's a way to fix it and test it and report it back. There's also something really cool about running your code in infrastructure that you don't control and that other people are using, and it's just really fun and neat to see other people using your stuff. So I'm just gonna go over really briefly for introduction what Sensu is. You've probably heard a bit about it over the last couple days from my colleagues. It's a monitoring framework that's positioned to be the end-to-end hub in a monitoring solution. Service and system checks are at the heart of what Sensu is and what Sensu does. There's a ton you can do with it. I'm not going to cover features really at all. I'm just going to tell you kind of how it works. Our community is really important as they've used Sensu in their own infrastructure and written plugins and checks and everything to contribute back so other people can use that. This makes it easy for folks who are new to the system to get started. V1 is written in Ruby on top of RabbitMQ and Redis. And the learnings from that process have actually led us to rewrite Sensu in Go over etcd, which I'll talk about in a little bit. This is just some of our community metrics for plugins. We have about 200 community-built open source plugins that are available for you to use, contribute to, and rebuild as needed. RabbitMQ is the transport layer. Redis holds state. Clients subscribe to the checks that they need to run, and actions work off a publish-subscribe messaging model. So this has been all well and great for 6 years of usage. People have been happy with it. People have been using it. We've run into some operational challenges that have made it painful for our users, and we want to pay attention to what that is and find out. So what are our pain points? Deployment, especially high availability, can be complex because we rely on someone else's technology that you have to install separately. Our engineering team at the beginning of, when we were first hired on, we had a chance to actually set up HA Sensu V1, and it was a really time-consuming and painful process, especially without config management. So it really relies on config management. Config management is awesome, but it's another added layer that makes it a little more complex. So what are our goals for a rewrite? I could probably give a talk on each of these topics. It's really kind of a lot of information, but the path to doing this was to spend almost a year in closed source development cycle, rewriting the entire system in Go on top of etcd to be more performant. It allows us to ship a couple of binaries that are easily installed by package management, Docker, and Kubernetes. And I can set something up and ready to go much more quickly with this solution than I could with V1. So just a super high level over architecture slide, but we still use a publish subscribe model, but now it's embedded in, on top of etcd, and you just run one binary. So open sourcing. We spent some time building this based off of the learnings from V1. Everything was pretty much one-to-one feature. We were just writing and shipping code for almost a year. This was actually a pretty unexciting process to talk about because we knew kind of all of the things that we had to do. These were all the known unknowns. We released Sensu V2 to the wild in February, and then started trying to get people to use it. So I'm gonna start talking about that process. So yes, this was our cute little baby alpha. We were very happy and excited about it. We knew it wasn't polished or perfect, but getting something out in the hands of users to see where our pain points are, what are things people liked about it, what were things that people were missing, and starting to get bug reports was really important, and it's important to do that early on in the process. So we started telling people to use it and say, hey friends, go use this binary in your infrastructure and tell me when it falls over, because it's gonna. And everyone responded like, where are your dashboards? This is awesome, this is super cool, and I love this, I love how easy this is, but like, there's all this stuff you're missing. Did you know this build is a month old on your, on Package Cloud? And we're like, oh no, we should probably fix that. We have nightlies now. Another question was like, when are you supporting clustering? They're like, I want to use this, but until you support clustering and high availability, I can't. And we're like, okay, these are good things to know, because now we know what's important to you. It's sometimes painful when you have your nice thing that you've built and you feel really proud of, for people to say like, okay, this isn't working for me, but then it's good to know and necessary so that you are building the right solutions. So we have done a ton of testing. How do we know our software works when we're not the primary consumers and we don't run any of this on our internal infrastructure? We did testing during development, but it was limited to unit integration and end-to-end testing. So this is like the gold standard of software development, is you write all these things and you're guaranteed that they work and everything is fine and dandy. But these tests are really useful for determining if the code is working during development, but not so useful for determining feature need, usability, or system behavior, because you're not testing in basically a real-world environment. So in order to get some benchmarks on how our system was performing or not, and the usability of that system, we had to do some different types of testing. Once we had an alpha and some information from users and space to breathe from our feature development death march, as Greg has called it, we started planning out what that testing looked like. Usability testing is actually kind of tough when you aren't the core user of your product, and especially when it's such a malleable framework. Like, there's a lot of flexibility in your system. We're not going to be able to test every possibility. Integration and end-to-end testing are really hard too, because they have a tendency to be brittle in some instances. Before I talk about that, I'll point out just a couple of things about code quality and some neat things that we've been trying. This is something we installed a couple of months ago called Velocity by Code Climate, and it's basically set up to alert us on the size of our PRs. So we're trying to aim for about a 200-line diff, which is easy for reviewers to actually look at and make sure that we're doing the right things. We're doing that about 50% of the time, and according to this graph, sometimes we're really good at it, sometimes we're not. But it depends. If you looked at this time last year, it would have been a completely different story, because we were working on different stuff. So this is a neat metric, but it's not like the end-all be-all of what code. Like, you can't determine this, you can't use this metric as a determination for like, is your code base keeping up with a consistent quality because it's changing over time as the features and bug fixes and cycles you're working on are changing. So this is another metric worth paying attention to. This is our build CI success ratio, and I'll point it out as just recently has been a really terrible metric for us. As something we've been wrestling with is actually getting our CI or test suite stable. And so this is pointing out, like, if we're having trouble with this, our users are gonna have trouble because we're not getting stuff out in a timely fashion if our builds are failing. So our end-to-end testing strategy actually proved to be a little bit brittle, and we're having to rework some of it. And so we're in the process of doing that right now. So user testing. Since we're still in the process of kind of gathering information from our community and getting our community to test it, we decided that we needed a QA process. So we all got on this call, and the Zoom call, all 10 of us or whatever it was. We wrote a doc and said, you know, what are all the features that we're trying to test? And what are all the things, what is our acceptance criteria? And then someone else who has not written that feature, go and test it. And this was really fun because we were breaking stuff left and right, or thinking we were because we hadn't documented it properly. So this uncovered a couple of bugs that were not major, but also a lot of bugs in our understanding of what the code base looked like and what the features looked like. But yeah, I'd highly recommend if you're doing any sort of like testing, and if you're not remote, if you're in an office, I'll go in a conference room and write these things up and go do them together. If you're remote like we are, get on a call and have everybody share their screens of what they're doing from time to time. It's pretty fun and enlightening. And then we did some load testing. So surprise, we have a tiny bit of infrastructure. We started to look at spinning up a single backend on Google Cloud and running a bunch of Kubernetes pods with agents in them to basically send checks and keep alives to our backend to see how many we could receive before it started falling over. We expect that we would push a button, have GKE spin up 10,000 agents or whatever the number was, and just start throwing data at it and expect to just watch it and fall over. In reality, we ended up load testing GKE because we were launching so many pods at one time that they were throttling us because we're like, what are you doing? This is kind of like a little bit not the best way to do this. So we went back, scaled back, and did something simpler, which is just running a single backend and then writing a script because everything is in a single binary, so we could write a Go program to just spin up that agent and spin up a number of them and then start sending data to our backend. And that was much simpler. And we were able to test it from like 2,000 connections until it fell over, and then we reported some bugs and fixed them, and then it was 5,000, and now we're at 10,000, which was our initial goal. So we can right now we're at 10,000 agents against one backend, which was pretty good for us now. So we found some performance issues, surprise, surprise. So now is where I get to talk about the fun bugs we found. So the first one we found was really entertaining. We discovered this a minute before we released our alpha. Someone was doing testing, and they had left a backend up and running and went back to test something the next day. They had thrown a bunch of test data, and they're like, hey, I can't actually hit the backend. It's just not working. And we started digging through the logs. It was completely unusable, and we see this MVCC database space exceeded. We're like, oh, that looks really bad. What is it? So we dug in and poured over etcd to try and figure out what it was. So etcd has something called compaction. Etcd is a key value store, and it keeps versions of all your keys. So anytime you update something, there's still an old version. So what we were doing is not throwing any of that data away and keeping it. And as we were doing a lot of writes, we discovered that we were hitting a default 2 gig size limit and running out of storage space. And so in turn, like we figured out, we don't actually need all of those old keys. We only need the most recent one. So we decided we can set the compaction level to just the most recent one, and also increase the size limit for the DB. But for some reason, it wasn't working. We were thinking, oh, we just set the compaction rate to keep 1 key space, and that'll be good. And we couldn't get it to work, and we couldn't get it to work. And then we finally realized we uncovered a bug in the etcd, which is what this comment is about. They basically were calculating the retention value off of time, and so it was throwing off our retention. We reported the bug, they fixed it within a week, it was wonderful, and then we were able to backport that fix and issue it, and now this comment is no longer in our code. So that was exciting. One of the other frustrating bugs we ran into was this, when I was talking about build quality. Again, this was a sometimes intermittent bug that we were running into with our end-to-end testing where it seemed to be randomly failing on one or two of these time window tests, which is a feature that we have to say, like, don't alert outside of these time frames. It looked normal. We had 2 or 3 people look at it. We're like, this code looks like it should work. I don't know why it's failing. We'll just, issue a bug and move on. And finally, like, we started looking at it, and I was like, maybe this is a UTC bug. And surprise, surprise, it was. Because what was happening is we don't always push code late in the evening. We don't always open pull requests after 5 p.m. Pacific, or like, I think it was 7 p.m. Central. We have people distributed. But at the end of their work days, most of the time, we were either leaving something for the next day or putting a pull request up early, or opening something earlier in the day. So we didn't often see this, so we thought it was random. But it turns out it wasn't. It happened at UTC midnight rollover, and we were calculating a year, month, day change off of something that wasn't localized to UTC. So a 6-character change fixed that, and a lot of our build frustration was like gone. And then the next thing that we found, this was a really perplexing issue, which is our bread and butter is check scheduling. If check scheduling doesn't work, our product doesn't work. We didn't see this in testing because we weren't often counting the number of the number of received events that we were getting from our checks. So we're just testing that these things were happening, but not actually verifying the number of events. So sometimes they would come in and work, sometimes they would fail to run the checks. We started kind of just adding a ton of logging and figuring out, we're like, okay, the agent definitely is not running these checks sometimes, even though they're getting scheduled every single second. We threw this on a 1-second interval just to see it happen frequently. So we were quickly able to narrow it down to somewhere in the transport between the agent and the backend, but from where? Who knows? We got 3 engineers on a call for like 2 days, a couple-hour pairing sessions. We were just kind of throwing ideas and spitballing stuff and really trying to figure it out. It was really tough to replicate. What it turned out to be was Go has the concept of channels in messaging. So between 2 separate processes, you can pass data through a channel. If the channel is closed, you cannot do anything with it. We were checking for the channel being open and we were checking for the topic or the channel's existence, but we weren't actually checking that we could use it. So we just added some more verification to make sure that was actually happening. We have a test for this now, by the way. So once we were done doing a bunch of bug polishing and released our alpha, and we thought, well, we have some documentation, but we really need to make this better. I love this quote from Jordan Sissel: if a user has a bad time, it's a bug. I believe this to be very true. I have had many bad times with documentation that seem like bugs, but actually aren't. It just wasn't documented correctly, or I was reading it incorrectly. That happens. And often, I want to avoid the case where I have to go dig through source code to find out how something works. We had pretty complete documentation for our alpha when we were starting to get to the point of launching our beta. We needed to kind of like rewrite it, so it was much more complete. Let's see. So our alpha documentation, yes, it was more like a circuit diagram than actually like, how do I use this thing? We had more information on how some features worked, how they were sort of different from our 1.x, but we kind of assumed a lot of things would just work the same. So we wrote a bunch of markdown docs, threw them in a GitHub repo, and said, here, go use this. Tell us if the documentation works. So it was okay. It definitely needed some improvement. So a colleague and I, oh yes, this is basically what our documentation looked like. We still have that repo up if you care to look at it as an example of like how not to do this. So we decided to polish our docs better for our beta release and make it so that it was a little bit better example of like, here's how you get started with something. Here's some context around why you might use this particular function or this feature, and then how it works underneath the hood so you can expand on it later. So my colleague and I tag teamed for about 3 weeks. Just like we hashed out a plan. We wrote a doc for how to write docs. There's more to this, but I didn't want to actually like, oh man, I totally didn't take out the spell checker before I screenshotted that. So we wrote this doc and a template, which made it so much easier for us to write consistent stories around a particular feature for how you would do something. And in particular, a guide, which is here's why you might want to use this, here's what it is, and then here's a quick and dirty like way to get it set up. And it does not go into a lot of detail, it just goes into enough to get you started. So this is what our doc site looks like now, or a little screen grab of it. It's organized, it's searchable. At the same time as we were writing Sensu Alpha, there was a rewrite of our doc site going on as well, because our users were having pain points with their docs. But this has references as well as the guides for things. So, the other thing I'll point out is our doc site is also open source, so users can file bugs and also contribute back to it when they see issues. So we've released Sensu to the wild. We've gone and released it to users. What do we do now? People are using it, people are happy, right? So we can't drink our own champagne. We really rely on our community's experience to drive the work that we're doing. So a couple of things we're doing or trying to do to get more information from users is something called test days, which I think we've run one so far, but it's basically like, try this feature, tell us how it works, or here's a demo of how this should work, and then let's get community trying it, seeing if it's useful, if there's something broken about it. We also love bug, and we're talking about experience reports. This is something we've kind of learned about from the Go community. The Go community loves experience reports, which is basically how did you expect this to work? How did it actually work? And what are you doing with it in your particular environment? We have a community Slack channel, and we're trying to drive that as well. So a lot of the initial questions about where are your dashboards and how is this actually working were all from our community Slack channel. It's kind of how we're doing a lot of our support right now. So with that, here's some resources, some links to some of the stuff that I've talked about today. I'm available for questions. People can basically go check that out. Go use our stuff if you feel like you have a need for this particular thing or not, or just tell us how terrible we're doing. Hopefully not. So thank you for listening.